Hi, good evening, everyone. So now today I'm going to take questions from question number 16 to question number 20 of ISI MSQE 2004 paper. Let's look into the question better. 5 boys and 4 girls are to be seated in a row for a photograph. It is desired that no 2 girls sit together. So try to understand this question. It says that 5 boys and 4 girls. So we need to first place the boys. So boy, 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 boy and boy. And now I want that girls should not be sitting together. No 2 girls sit together. So girl can come here, 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 here or here. So when girls come in this in this position, right, then the girls would not be sitting together. Okay, the number of ways in which this can be arranged can be. So try to understand that first of all, I can go ahead and I can arrange these boys. So I have 1, 2, 3, 4, 5. So these boys can be arranged in 5 factorial ways. Boys into. Now I need to go ahead and arrange the girls. So try to understand that girl can come here, 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 or here. So I have 6 positions, out of which I need to fill the 4 positions, right? So there will be 64 ways to go ahead and arrange the girls, right? So, I mean, not arrange. So out of 6 positions, I need to pick any 4 of them, right? And then you need to go ahead and understand that then the girls can also be arranged, right? Just I have the first girl as Anita. I have the second girl as Serima, right? So first I pick any 4 places. So I pick, okay, I want girl to be here, 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 and here. Then these girls are not together. Then I can have Anita here, Rima here, Seema here, and Mona here. Or I can also have Rima here, Anita here, Seema here, and Mona here, right? So among themselves also these girls can be arranged, right? First, I am picking 4 positions out of 6, and then I can go ahead and arrange these girls in 4 factorial ways, right? So what would be my answer? 5 factorial into 6c4 into 4 factorial. So I will go ahead and solve this out. So I will get 5 factorial into 6 factorial, 4 factorial, 2 factorial into 2 into 4 factorial. So this will be 5 factorial into 6 factorial by 2 factorial. Now notice that this actually turns out to be the formula of permutation. So when I have 6p4, it gives me 6 factorial by 6 minus 4 factorial. So this part can be written as 6p4 and this will be 5 factorial. So ultimately, this will give me 5 factorial into 6p4 and that would be the answer to this question. So answer will be A, right? Okay, come to the next question. It says that there is a point which moves so that the ratio of its distance from the point minus A0 and 0A is to 3. So I have a point xy. Let the point be xy. Now we need to find the distance of this point with minus A comma 0. So it's like this. Right? So let's say that, so minus A comma 0 will be here, right? And A comma 0 will be here, right? And I have a point, say x comma y, right? So I can take x comma y a bit towards this side rather, right? Now when I find the distance of this is to this, that is 2:3, right? So this distance is to this distance, that is 2:3. So just try to find this distance out better. What would this be? So minus A minus x whole square plus y minus 0 whole square. And then try to find the other distance, A minus x whole square plus 0 minus y whole square, right? They are in the square, so it does not matter whether I do first coordinate minus second or second minus first. Just try to follow the same. So if I'm doing minus A minus x whole square, you can write 0 minus y whole square here, right? But it does not matter. It is in square only, na? So it won't matter. It is just first coordinate minus second coordinate whole square plus second coordinate. I mean, you could have done x minus a whole square plus y minus 0 whole square. उससे फर्क नहीं पड़ेगा. You're getting it, right? This is in the square. Distance is in the square. So it does not matter whether you do 2 minus first coordinate minus second or second minus first, right? Okay, then this is under root equal to 2 by 3, right? So beta, I will square both sides then, right? So from here, I will get minus a minus x whole square plus 0 minus y whole square upon a minus x whole square plus 0 minus y whole square is equal to squaring both sides 4 by 9. Distance का formula याद रख लो, x2 minus x1 whole square plus y2 minus y1 whole square under root. ये distance का formula. I'm just using that formula here. Right. Achha, now what you can do is just open this up. So this will be minus a whole square plus x square plus 2ax plus y square upon a square plus x square minus 2ax plus y square will be 4 by 9. So 9a square plus 9x square, just cross multiply, plus 18ax plus 9y square will be 4a square plus 4x square minus 8ax plus 4y square. Okay, now just try to solve this. This will go here, 5a square. This will go here, plus 5x square. This will go here, plus 5y square. This will go here, plus 26ax equal to 0. So answer will be B. 5x square plus 5y square plus 26ax plus 5a square will be 0. So B seems to be the right answer. Okay. Here is the next question. Yeah. Okay, try to see this thing. So it says if the sum of this when divided by 36, the remainder will be. So very good and interesting question actually. So try to see this question better. So notice that here it is saying that you need to sum the factorials and your x goes from 1 to 100. And then whatever the sum comes out to be, you need to divide that by 36. So what I can do is I can just start summing. So 1 factorial plus 2 factorial plus 3 factorial and so on till 100 factorial. And I need to see what happens when I divide this by 36. What's the remainder? Let me look into first the sum. So now notice that, ध्यान से सुनना मेरी बात को. Try to see that when I find 3 factorial, this is 3 into 2 into 1. So this is 6 into 1. When I find 4 factorial, this is 4 into 3 into 2. So this is 30. This is 24. This is 6. When I find 5 factorial, this is 5 into 4 factorial. So 5 into 24. So 120. Right? Till now, I haven't seen anything getting divisible completely by 36. Are you getting it? So if I just find 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus 7 factorial and so on, I see that this gives me 1, this gives me 2, this gives me 6, this gives me 4 into 3 into 2, which means 24. This gives me 120. Till now, I haven't seen anything getting completely divisible by 36. Now come to 6 factorial. 6 factorial is 6 into 5 into 4 into 3 into 2. So notice here that I am getting 3 into 2, which is 6. 6 into 6 is 36. So what I get here is 36 into 20. So that means that 6 factorial will be divisible by 36. 6 factorial will be divisible by 36. If 6 factorial is divisible by 36, then beta 7 factorial is simply 7 into 6 factorial. 8 factorial is simply 8 into 7 into 6 factorial. So all the consecutive numbers will also be divisible by 36 because 6 factorial gets divisible by 36, right? Now try to understand that I need to find out what will be the remainder when this entire thing, so on, is divisible by 36. So it will be equivalent to 1 factorial by 36 plus 2 factorial by 36 plus 3 factorial by 36 plus 6 factorial by 36 plus 7 factorial by 36 and so on. Now from here onwards, these are completely divisible by 36. So I will get no remainder. So this will be gone. There will be zero remainder left in these cases. So the remainder that I will be getting will be from the sum that I get from 1 to 5 factorial. And now I know that 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120 divided by 36, right? So this gives me 30, 150, 153. So 153 divided by 36. And when I will just divide 153 by 36, so I will get the remainder as 9. So the correct answer to this question should be 9. The remainder will be 9. Am I clear with it? Okay, come to the next question. It says A, B, C are in AP, sorry, are in GP. Then what happens to A cube plus B cube? So just try to open this up. To the power minus 1 is given. So this will be 1 upon A cube plus B cube, comma, 1 upon B cube plus C cube, comma, 1 upon C cube plus D cube. So you need to find out whether if A, B, C and D are in GP, then what happens to these terms. So you need to see that if I talk about the term, because A, B, C and D are in GP, so I can say that B can be A times some common ratio. C can be A times B, which will be A times AR. So it will be, sorry, A times R square. Again, multiplying it B times the common ratio, right? So C can be B times the common ratio. So it will be AR into R, so AR square. D can be C times the common ratio, so AR square into R, so AR cube and so on and so forth. Right? So now what you can go ahead and do is you can just try to plug in these values here. So if I just plug it here, I will get 1 upon A cube plus, instead of B cube, I will write AR whole cube, right? So if I just try to solve this out, I will get 1 upon A cube plus A cube R cube. So I will get 1 upon, take A cube common, 1 plus R cube. All right. Now look into the second term beta here. So I will go ahead and I will have, so instead of B, I will write AR whole cube. Instead of C, I will write AR square whole cube, right? So here I will be getting 1 upon A cube R cube plus A cube R to the power 6, right? So if I just go ahead and I take A cube R cube common, I will be left up with 1 plus R to the power 3. When bases same power gets added, so 3 plus 3 will give you 6, right? Okay, then you go for the third term. So here you again go ahead and you will just put down these values. So you will have 1 upon AR square whole cube plus AR cube whole cube. So this is going to go ahead and give you 1 upon A cube R to the power 6 plus A to the power 3 R to the power 9. So this is going to go ahead and give you, I will take A cube common, R to the power 6 common, 1 plus R to the power 3. When base is same, power gets added. So here the base is same, power will add up and you will get the power as 9. Okay, now just notice that these also appear to be in GP, right? These also appear to be in GP. And what is their common ratio? To find the common ratio, you can do the second term divided by the first term. And when you will do this, you will be left up with 1 by R cube. So when this one is multiplied with R cube, right, in the denominator, you will get the second term. Again, multiplied with R cube in the denominator, you will get the third term. So clearly these are in GP with the common ratio as 1 by R cube, right? Okay, beta, come to the next question. So this says find the solution of the inequality, and you are given that the inequality is mod x minus 1 less than 1 minus x. Now, there are multiple ways to go ahead and solve this kind of question. One of the very easy way in which you can do is through the method of hit and trial also, right? So what you can go ahead and do is you can just try to plug in some values right here. So let's say I start with the lowest interval possible between minus 1 to 1. So let's say I take the value as 0.5. I take the value as 0.5. So if I just take any value, say 0.5 minus 1 less than 1 minus 0.5. So I will get 0.5 minus 1 less than 0.5 minus 0.5 less than 0.5, 0.5 less than 0.5, it is false. So if this is false, it means that option D seems to be incorrect. This is an incorrect option. Then you go ahead with the next option because 0.5 belongs between 0 to infinity, right? And I have already negated 0.5 from here. It means that option C is also negated. And because 0.5 also lies in the interval minus infinity to infinity, and I've already negated 0.5, so this is also negated. So therefore, the correct answer to this should be option number A, right? So by taking one number, I have been able to go ahead and I have been able to understand that the answer should be A, right? Now you can also go ahead and go through the actual mathematical process of going ahead and solving this. Am I right with that? Okay. So now you can go ahead and just do this mathematical process. So you're given that this is your inequality. So you can just go ahead and remove this absolute value. And you can say that it will be 1 minus mod x less than 1 minus x if mod x is less than 1, right? And if you go ahead and if you try to further open this up, you will get 1 plus x less than 1 minus x if x is between minus 1 to 0. And 1 minus x less than 1 minus x if x is between 0 to 1. Now, 1 minus x cannot be less than 1 minus x, right? The two things are absolutely equal to each other. So it makes no sense and this would be cancelling it out. So then you will be left up with 1 plus x less than 1 minus x when x is between minus 1 to 0. So 2x less than 0. So x less than 0. So x less than 0 lies in this interval between minus 1 to 0. So yes, this statement holds true. Then you can go ahead and see what happens when x is less than minus 1. So minus x minus 1 less than 1 minus x when you open up this mod, right? And this will give you minus 1 less than 1, which means that also always holds. So therefore, this equation holds when x is less than minus 1. This equation holds when x is between minus 1 to 0. So it holds when it is between minus infinity to 0. Now you will notice that when x is greater than 1, the equation will not hold. So you will go ahead and get the answer as minus infinity to infinity. But I kind of, if you find this to be confusing, opening this up and solving, I kind of, want you to take an example, a number, and just try that. That will be the easiest thing to do and solve it, right? Okay, beta. Thank you.